This is a Friday Shoes production. Today's target, I can graph quadratic functions. Follow along on page 534. Let's take a look at graphing quadratic functions. Well, first, a quadratic function, like y equals 3 times x to the second power, is a function where the greatest power of the variable is 2. And if you notice, we're talking about that 2 right there. The graph of a quadratic function is U-shaped. It's called a parabola and opens upward or downward. Take a look at example 1 from the book. When you graph quadratic functions, you have to make a table of values, plot the ordered pairs, and connect the points with a smooth curve. Notice that's highlighted. Now, the first example, they have graph y equals x to the second power. Notice it is quadratic because it has the 2 there. And if you look at what they've done, they've taken the x values of -2, -1, 0, 1, and 2, which we have always used on linear functions, and they've plugged them in to the function x squared, done the math, and received out their y values. Of course, they then put them into ordered pair format, which is that last column. Once they have them written in the ordered pair format, of course, you can plot those points, and I've color coordinated them so that you can see where they locate on the graph. They then draw a smooth curve. That's what this says up here. They draw a smooth curve through the points. So I'll trace what they mean. You're drawing a smooth curve through those points. You don't literally connect the dots, you make a smooth curve. It's not the greatest, but there it is. Let's take a look at example 2. Graph y equals -2 times x to the second power. Notice it's quadratic because it has the 2 there. They've taken their x values, the same ones that we use. They've plugged in the -2 into the x value in the function right here. They've squared it, raised it to the second power. That equals 4. So -2 times -2. Then they've multiplied it by this number right here, -2, which is in front. So it's a 4 times -2, that'd be -8. They've shown all the work for all the problems here, plugging in all of the x values, gotten out the y values, and then written them as ordered pairs. Of course, they plotted. Notice this one here actually is opening downward. The reason why this one opens downward is because of this right up here. Negative coefficient, the -2, the number in front of the x, if it's a negative coefficient, it'll open downward. Looking at the original problem, x squared, what's in front of that x? If you remember, there's a 1 in front of that x, and that 1 is positive, therefore it will actually open upward. So you can see this is a U shape going upwards, and that 1, the coefficient, is positive. Let's take a look at example 3. Same concept. They plug in their x values into the x for the function. -2 times -2 equals 4. If you try that on a calculator, make sure you use parentheses. When you put -2 to the second power into your calculator with parentheses, it will give you 4. If you just plug this in and raise it to the fourth power, or raise it to the second power, this will give you -4. The reason why is it will actually do 2 squared first, then put a negative on it. It's the order of operations your calculator has. So please use parentheses on your calculator. Again, they plugged in the x values, gotten out the y values, and then they're going to graph these points, as you can see over here. Notice what's in front of that x squared? A 1, the invisible 1. That's a positive. That's why this opens upwards. Something else I want to point out. The equation is y equals x squared plus 2. This plus 2 will guide us as to where the focus point, or what you might call the bottom of this parabola is. Notice that orange dot right there is located at positive 2 on the y-axis. So this spot will tell us where this parabola will cross the y-axis, its y-intercept. Let's take a look at example 4. Graph y equals negative x squared plus 4. Well, take a look at what they've done. Again, they've taken the x values and they plugged them into the x here. I want to make this real clear, though. Notice this negative sign right here. That negative sign is still right here. So when they plug negative 2 in for the x value, they don't get rid of that negative right here. They don't get rid of this negative. It is actually still there. So we have the opposite, which is this, of negative 2 to the second power. When you do the math on this, we're going to do this first, because exponents come first. Negative 2 times negative 2 is 4. Then we're going to put a negative on it, so it'll be negative 4. And then we're going to add 4. That's why it is 0. Same thing here. Negative 1 squared is going to be 1. Put a negative on it. Now it's negative 1. And we're going to add it with 4, and we get 3. Continue the pattern. And then, of course, write them as ordered pairs and graph. Notice the number in front of the x on this equation up here is actually, if we put our invisible 1 in there, it's negative 1. So it is going to open downwards. Also notice our plus 4. The y-intercept does cross, the parabola does cross at the y-intercept of 4. Now for you. If you print the notes for this page, you can have the nice tables right here, and you can have the graphs right here. But I'd like you to try each one of these on your own. Answers will be provided in class. And as usual, don't forget, you can always rewatch this video or read the examples in the book. Or you can go online and do the personal tutor. This has been a Friday Shoes production.